Hello there. We're going to do a quick demo here tonight talking about a memory leak and how we can track it down, the sorts of things we look for, the tools we use. This example was put together by our very own Peter Carlson, or How You Do That, in our chat and our mailing list. He built a very simple application here that demonstrates it with a handy little set of instructions with this super helpful just /run. And it will fire up the server and dev mode and let us take a look. This application is going to depend on Domino UI. He originally wrote this to allow us to test a bug in his own application and tried to distill it down to its simplest case. And the example code he built here, let's see here, let me get things started up here. A little bit off screen, you'll see it in a moment, great. And then 8080, there we go. So we're compiling here, and while that's happening off screen, we're going to look at this. So there's an example app that's going to have an app layout, and in the header it's going to have a rebuild button, which will rebuild the whole UI. There's a timer that will every second tick and rebuild some content, some data in a data table. And then you can also hit a single button to have this trigger just once. The reason we want to trigger this just once is because when we're hunting memory leaks, while it's helpful to have a user's accurate and full experience to know that they're leaking a substantial amount of memory, it's also helpful to be able to distill this down to a single object leaked and say a new object was created, no object was cleaned up, where was that new object created so we can track back, or where were the old objects created and why are they still being retained so we can track backward and figure out what happened. Our initial thinking was that somehow when you created a new object and you stuck it in the data store, the old one was still being kept, even though we were updating an existing one. Somehow we were leaking that and loads of other memory. So once we've got this application up, let's pull open our dev tools and then memory. We're going to run this a couple of times. That way we've got at least some memory used, let the application settle in with regards to jitting and whatnot. And then we're going to take a heap snapshot. So we've got a baseline. And then with that baseline, once that's fully read in, we're going to have it leak the smallest amount of memory we can, what the smallest action is we can take that'll cause a leak. And this takes a while to build. It's not a small set of data because, again, we wanted to make sure the bug could still be reproduced in this example, which makes it much easier if we can leak a lot of memory quickly. All right, there's our first one. Then we'll leak one object, ostensibly. We'll create one object, we'll replace it in the data store, and then we will snapshot again. Now, this demo may go awry here because I did make the mistake of leaving this set up to use head snapshot, and that may pick up a build where this bug has already been fixed. It's already been discussed somewhat in the chat room. So we now want to compare before and after to say what objects were created, what objects were deleted. We got 17 more megabytes in the second snapshot. And we want to figure out where those might have come from. What kinds of objects did we create more than we deleted? So these are kind of a lot of other objects created and the old ones not deleted. The fact we see this suggests there may still be a leak even though we think we fixed it. So there's a lot of these where it's a delta of 0. There were 160 new objects created and 160 deleted. So we know that that was cleaned up pretty nicely. There are some net negatives, but for the most part, we've got a lot of net positives. And we want to see what those objects are that are leaking. 0 menus were deleted and 40 were leaked. So let's look at that and figure out what is leaking menu instances. Now, these are the new instances. New objects that are still retained by the application. We want to look at the old menus and say, okay, of the old menus, which menus, sorry, let's say that again. We want to look at the old menus that perhaps should have been deleted but weren't and figure out why they're still retained. So we'll go over here, we'll find some number less than 729 for its first 3 digits out of 7. And we'll look for menu. So all of them, basically, are going to be 729. We think some of these, anyway, should have been deleted. Perhaps not all of them, but some of them. And then we'll pick one, and now we've got a couple different views we can take here. We can say, show me what fields this has and what those types are. And then we also have this view that says, show me what was holding on to this object here. So it looks like when this is recreated, we are leaking a menu instance. And we want to understand for any one of these objects, what is holding onto it. And it looks like the first thing that's holding onto it in the global window is this all uppercase listeners, right? So as a Java convention, especially with super dev mode running, so we can see it's Java, if we have all caps, that implies that this is a public static final or private static final, but it's a global, and it's not going away, and this will never be cleaned up. And the fact it is a hash code map suggests that it is a map of some kind. We can't see where listeners is, unfortunately. It doesn't show us that in our what do you call this? Source maps. But we can see that it's a hash map of some kind, and the hash map eventually points at all this mapping stuff to eventually look up an entry, and the entry object is a menu lambda of some kind. So we could look at the menu type and figure out what a lambda is, which lambda it was, rather. But it could be one of many lambdas. It's kind of hard to hunt that down. This is pretty helpful. It actually tells us right away what this is. So it's this lambda here. This is leaking the outer this because it holds a reference right here to this. And by holding that this, which is the menu itself, we have to leak the whole thing until whatever this is goes away. So unfortunately, this is a little hard to browse at this point, so we'll kick over to IntelliJ. We'll look at menu in Domino, and that was line 361, which is right here. So it's a media query add on small and down listener. We flip some Boolean here to figure out how to change the menu. So we're waiting to see if that is, if we hit small and down and this is set, then we do this. So don't really understand what it's doing with that. So looking at the signature here, it looks like this is an event listener, basically to say when media queries change in some way, I want you to move your menus. And on the left side of the signature, we see that it returns a media query listener record, which presumably is a way to perhaps unload that. So there's an add listener call here that's small and down. Add listener is here, which will make a little lambda, which will check and then call your listener. And then it returns a lambda, which we'll call remove. So technically, we could look for remove calls, because that's going to be an on small and down remove. Remove on small and up, on small and up, large and down. There's a lot of these. I don't know the code, so I'm going to embarrass myself. I don't see calls to this being made, so we could instead look for the calls to remove. The remove calls are all going to be private, so they're all going to be in this class itself. So basically, this boils down to we are looking for anything that would use this return thing here. And it looks like we just drop this returned object here. So when the menu intends to be garbage collected and it's no longer going to be used, media query still holds a reference to it. And because media query still holds a reference to it, the object ends up leaking. So it seems that I haven't actually downloaded the new update. Perhaps it was just deployed to a new version rather than hitting a head snapshot first, or perhaps I've somehow avoided the update. But that's the basics of it. We use the memory tab to take a snapshot before and after the smallest leak we can. We take a look at the object itself. Sometimes we get hints in the fields to figure out what kinds of data it holds, it itself holds, or we look at who is retaining references to that object and work backward from there. Now, in this case, we got really lucky that the first deep entry pointed to this listeners itself. And if we look for some other examples to say, okay, who else is holding this? If we collapse backward, we've got this element here in an array, which also points back to listeners, but also host, which is also part of listeners. So they're all the same listeners over and over again. And by the way, just to close the loop there, listeners is this field here. It looks like this is the correct one. And we can look that up in IntelliJ. IntelliJ has this handy symbol search. So we can type listeners here and tell it not just our project, but look in all places. And we see that the only symbol, which would look for fields and methods both, is called listeners with all caps in media query itself. So we're fairly confident that that is the instance that's holding our reference. Until this goes away, it's final, so it won't be reassigned. And we only have a couple of calls to it here. We have this put. We have a remove, which we already determined wasn't called. And then we have the initialization. So we're fairly sure. We don't actually even have sources here. That's irritating. The sources are in the same file, so this has got to be the source version. It's not. Here it is. Here's the real thing. Okay, there's JavaDoc for this that explains it and some comments that tell us what's going on. Okay. Anyway, so once we found this reference, we can work our way backward. So that is the same reference. Here's a listener, which again takes us back to listeners. So it appears pretty much all roads lead to listeners, and that is the root of our leak for this particular object. Another one taking us back to listeners. Let's scroll down a little ways. Here's a whole bunch of lambdas that are attached. And any given lambda it takes quite a ways to get here. So this is probably a lambda that's attached to one of the elements inside of the map, probably the menu, probably the contents of the menu, and it eventually drags us all the way back to listeners. So how do we solve this? How do we remediate this? I believe that some mitigation is in place for a couple of the classes, but not for all of them yet. For this particular one, we need to have listeners be either hold weak references. So that's a JavaScript type, which allows us to say, allow this object to be garbage collected, allow the value, or the key or the value. How's this phrased? I haven't actually dug in here yet. It looks like the key. Allow the key to be garbage collected. Of course, you can't hash a weak ref, so we would have to end up building our own weak ref map of some kind to be able to work this out. At some point, we have to be iterating listeners to call all the listeners that apply to this. So something in here is doing that, and I haven't worked out exactly what it is yet, but that'd be an interesting journey. Anyway, we need to, the other option is that we retain a reference here to the lambda that gets returned and say, go ahead and clean me up when we're finished. So we look for, how do we know when this menu has been detached and no longer needs to keep track of its references anymore because it's out of the DOM. So the one we looked at the other day was the popover, and the popover very early had a media query. So we are just looking at an old copy of the code. I ended up not getting a newer copy of the code because this is the first leak that I found. I happened to see the popover because it was in the pop picker. That came from another path for figuring this out. The developer who knew his own code and was able to say, I think it's probably the pop picker. And if we look real quick at pop picker, we can see also that it leaked 20 instances. And we can say, okay, of these 20 instances, 729, let's go back before that. There's 100 here. Pick the first one, and once again, it leads us right back to listeners. So there's a number of places where listeners needs to let go of its references, and if it does, this leak should go away. Thanks for hanging out. I hope this was helpful.